Hello everyone. I wanted to give you a video solution from the latest test because I noticed that many of you struggled with the kind of question, and although these were very simple, easy questions that you could do with the knowledge that you had about arithmetic sequences and series, I do think that there is a creative component to all the questions that you guys need to develop, and the only way to develop that is through constant practice, and you are not there yet. So instead of solving this exam in class, I wanted to make a video of it so that you can come back to it and then maybe look at whatever piece of the solution you need to study over and over. You can always come back to it. The first question of the test read, some steps are to be built using identical bricks, each in the shape of a square prism. The following diagram shows how 18 bricks can be used to build 3 steps. And then we have here the diagram. Calculate how many bricks are needed to build 20 steps. So one key element in this question is that they told us that this diagram that we are seeing here consists of 18 bricks, and that is an accumulated amount of bricks when building 3 steps. So we're going to count the steps. This would be step 1, this would be step 2, and this would be step 3. If we're building step 1, we can see from the pattern that we needed 3 blocks to build a step, 1, 2, 3. However, for the second step, we needed 6, 1, 2, 3, and then 3 in the bottom. That makes 6 steps. And then for the final step, we have 3 rows of 3 steps each, so that is 9 bricks. So 3, 6, 9. You can see that this sequence, 3, is just plus 3 all the time. Therefore, it is an arithmetic sequence. Now, where are the 18 bricks? The 18 bricks come from the sum of 3 plus 6 plus 9. 9 plus 3 is 12, plus 6, 18. So actually, 18 is S3, the sum of the number of bricks in the first 3 terms of the sequence. Right? That is the information that was given in the question. Now they say how many bricks are needed to build 20 steps. So with this same logic, when they ask us to build 20 steps, that means 20 steps in total. So they're also asking for S20. How many bricks in total would I need to have in order to build 20 steps? Now the first term of the sequence, we're going to call it A1 is 3, A2 is 6, A3 is 9. Then we know the common difference D is 3. So we can go to the formula that we know for Sn is n over 2, 2a1 plus n minus 1 times the common difference. If we substitute the values that we need, so S20, this would be 20 divided by 2 times 2 times the first term, which is equal to 3, plus 20 minus 1 times the common difference, which is 3. Simplifying this is 10, this is 6, 19 times 3. If we do 19 times 3 first, then we add the 6. So 3 times 9, 27, carry 2, 3 times 1, 3 plus 2, 57. Then we do the times 6, so 10 times 63, and this is equal to 630 bricks. Now for the remaining 2 questions, they were optional, so you may want to see how both questions were solved, but if not, then feel free to skip to the correct question that you want to see. We'll start now with question number 2. This question read, equal length sticks are arranged to form an equilateral triangle which together form a larger equilateral triangle. The first 3 steps are shown below. Sketch the arrangement of sticks in step 4 and summarize your results in the table below. Use any patterns you notice to find unknown values. Consider the total number of sticks S at step N and find an expression for S in terms of N. So basically what they are saying is we have some sticks that we are using to build triangles. So for example, in step 1 we have a triangle formed by 1, 2, and 3 sticks. Step 2, we have a triangle that is formed by 1, 2, 3, 4, 5, 6, 7, 8, and 9 sticks. Then in step 3, we have a little bit more sticks making a bigger triangle. What would be the next shape? That is the first question that we need to resolve. So the first shape would be to add one more row to the triangle that we already have. So let's reproduce triangle number 3, step 3. So that would be step 2. And this would be step 3. Now we need to add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 more sticks to make step 4. Alright, for part B, we need to then start counting how many sticks are in each of the first few steps so that we can figure out what the pattern is. So in step 1 and step 2 they are given. We have 3 sticks in step 1 and 9 sticks in step 2. In step 3 we can count them. We have 3, 6, 9, 12, 15, 18 sticks. And in stage 4 we have 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30 sticks. Now, stages 5 and 6, we could figure out what we're going to have either by drawing the next few steps or by figuring out the pattern, right? For example, for stage 1, for stage 5, all we would need to do is add 1, 2, 3, 4, and 5 more triangles to step 4, meaning we're adding 5 times 3, 15 new sticks. So that makes for stage 5, we're going to have 45 sticks. And for step 3, we're going to add 1, 2, 3, 4, 5, and 6 new triangles. So that means 18 additional sticks. So that means that we're going to have 45 plus 18, and that is equal to 63. 63 new sticks. All right? Now, what we want now is actually figure out the pattern that we were talking about for this sequence. All right? One way to do that would be to recognize that at each stage we are adding a new number of sticks. So these are actually sums. The number of sticks on each stage is a sum. So let's figure out what these sums are. In step 1, the sum, let's call it S1, is 3. In step 2, the sum, let's call it S2, is 9. In step 3, let's call the sum S3, that is 18. So if we look at these numbers, just based on these 3, we don't need to use the next ones. I want to see what the terms of the sequence are in order to understand what it is that I'm working with. Now, the topic of the test was arithmetic sequences. So I should, by context, know that this series or that these sums correspond to arithmetic series. However, in a bigger test, you don't necessarily have that context, so you would need to do a little bit more digging to see what it is. And so the general way that I would recommend you do this is to try to find a few terms of the sequence by subtracting consecutive terms of the sum. For example, A1 directly corresponds to S1. So A1 is 3. S2 would be the sum of A1 plus A2. So that means that A2 is going to be S2 minus S1, which is, let's do it here, which is 9 minus 3, that is 6. And then A3, what is A3? A3 is A1 plus A2 plus, S3 is A1 plus A2 plus A3. So A3 is going to be the sum of the first three terms, S3, minus A1 and minus A2. That means minus S2. S2, remember, is the sum of the first two terms, so minus A1 plus A2. So we know S3 is 18, and we know S2 is 9. 18 minus 9 is 9. So A3 is 9. Now we look at these numbers. A2 is 6, A1 is 3. This is a geometric sequence with a common difference 3 and first term equal to 3 as well. So in order to do C, that says find an expression for S in terms of N, we need to substitute into the formula that we have in the formula booklet, 2A1 plus N minus 1 times common difference, but substituting the values that we have, keeping the expression in terms of N. So N divided by 2, 2 times A1, which is 3, plus N minus 1 times the common difference, which is 3. So this is N divided by 2, 6 plus 3N minus 3. This would be equal to N divided by 2, 3N plus 3. And then there's nothing else we can do, so we can leave the answer right here. But the key to this question was to identify that these are sums. These are not the terms of the sequence. These are sums. And using the context that these were arithmetic sequences and series, you would know that these are sums of an arithmetic sequence. Therefore, if we do the subtraction between the two consecutive terms of the series, we can find the arithmetic sequence, the terms of the arithmetic sequence. Okay, let's move on to number 3. Now the final question in this test, which you could have chosen alternatively to the previous question, number 2, said the sum Sn of the first n terms of an arithmetic sequence is given by this formula. Find the 50th term of the sequence. So this question, although it looked a little bit more complicated than the previous one, was the easiest of all the questions, including question number 1. The key to this question is to recognize that this is the expression for the sum. So if I want to find the sum of an arithmetic sequence, I already have the equation. They want me to find the 50th term of the sequence. With that equation, I can only find the 50th sum, or the 50th partial sum for the arithmetic series. So I'm going to start with that as 50. And before I use the formula, I just want to recognize what this is. This is the sum of the terms A1 plus A2 plus A49 plus A50. That is what S50 is representing. So from this expression, I can see that if I want, I can do a collective of the first 49 terms and call that the sum of the first 49 terms, and that is represented with the symbol S49. So this becomes the equation S50 equals S49 plus A50. Now the question is asking for the 50th term of the sequence, and I already have it here. I already built an expression that will allow me to find it. So I'm just going to solve for A50. So A50 is going to be S50 minus S49. Now, I already have a wonderful equation given to me by the question that can help me find S50 and S49 just by substituting the value of n. So this becomes S50, let's do them here to the side. S50 is 2 times 50 squared minus 4 times 50. And we just plug that into our calculator. And we get the value of 4,800. And we repeat that for S49. So 2 times 49 squared minus 4 times 49. And that is 4,606. So when I put the two values here, subtracting 4,606, I find that A50 is 194.